Number 6, let f be this function, the integral from -1 to x of cosine of t cubed dt on the interval from x equals 0 to 2. Find the interval in which f is decreasing. Okay, so f is decreasing when f prime is less than 0. So we need f prime of x. That's quick and easy to get. We replace t with x. So f prime of x is the cosine of x cubed. So now we need to know when this function, cosine of x cubed, is negative on that interval from 0 to 2. Let's go to the calculator. So we have our, turn off the, there we go, get that out of the glare. Okay, so we've got cosine of x cubed in for y1. We need to take a look at the graph and at the window button. We're only interested from 0 to 2. So you can see x min is 0, x max is 2, and I put my y min and max near the x axis. All right, just down a unit and a half and up a unit and a half. So if we hit the graph key, there's our picture right there. We're interested when this graph is negative. In other words, when this graph is below the x axis. So we can see we got a large chunk right there, and it looks like a small chunk at the very end. We've got to find those values. Okay, we do that through the zero finder, the calculate menu, which is right there in blue above trace. So second trace, we want the zeros. Okay, the left bound, well, the first time it happens looks like it's just after x equals 1. So let's make our left bound 1. Okay, and our right bound, well, we don't have to go too far, but let's just go 1.5. Alright, we know that we cross the x-axis somewhere in between, so it's going to do the intermediate value theorem. It looks like it's about 1.2-ish, so let's put that in as our guess. And in fact, it's 1.162. Alright, so our first interval, 1.162, and that will go until we have to find out this second time the derivative crosses the x-axis. So we're going to hit it again. We're going to go second calculate, option 2 for 0. Okay, we'll pick up 1.5 now can be our left bound. All right, and our right bound somewhere over here it's like 1.75. Right, so right bound 1.75. All right, we can see that we definitely crossed in between those bounds. When it was close to 1.75, so let's just guess 1.7. And it's going to look, and we see that our answer down here, 1.6765. All right, so from 1.162 to 1.676, that is one interval on which our derivative is below the x-axis. In other words, our derivative is negative, and therefore the function is decreasing. Now we have another one which is going to go until we hit 2. Okay, right here at the very end. We have to find out when it starts being negative. It's going to be pretty close to 2. So we got to do this one more time. So second calculate, option 2 for 0. We know it's pretty close to 2, so let's just call it 1.85 as our left bound. And 2 will be our right bound. And we can see that it's very close to the edge, so let's just guess 1.95. And in fact, it's 1.9877. So from 1.9877 to 2, our derivative is also negative, and therefore our function is decreasing. All right, G is asking something similar, except it's concave up. This will be same idea, except we're not going to use the calculator for this one. So concavity is the second derivative. Let's get our first derivative. G prime is x squared minus x cubed, which means g double prime of x is 2x minus 3x squared. We're interested in concavity. That means we need to find when our second derivative is equal to 0. Okay, well, we have an x in common, so if we pull that out, we're left with 2 minus 3x equal to 0. Well, we cover these up one at a time, like so. If we cover up the second one, we see that x is 0. That's one of our possible points of inflection. We cover this up, all right, well, 2x minus 3 equals 0, so 2 is equal to 3x, and x is equal to 2/3. That's our second possible point of inflection. What do we do with these points? We place them on the number line. So we have 0, we have 2/3. And now we've got to check out some values to the left of 0, to the right of 2/3, and in between. To the left of 0 would be -1. If we plug -1 in, I'll change pens here, -1 in for x, right, we get ourselves a negative. Okay. If we plug -1 in here for x, we have 2 minus -3. That's 5, that's positive. So we end up with a negative times a positive, which is a negative. Now we need a number between 0 and 2/3, so let's pick a half. X is a half, so it's positive. 3/2 is 1.5. 2 minus 1.5 is also positive. Positive times a positive is a positive. Now we pick a number to the right of 2/3. Let's pick 1. X is 1, that's positive. If x is 1 here, 2 minus 3 is -1. So that part is negative. Positive times a negative is a negative. What does this tell us? Well, we're interested in when G is concave up. G is concave up when G double prime is positive. So our interval is from 0 to 2/3.